We have already looked at how the elements in the periodic table are ordered horizontally by increasing atomic number or increasing number of protons. Due to this ordering, the elements are arranged into groups and periods. The groups are vertical and the periods are horizontal. There are 8 groups in the periodic table. Groups 1 and 2 are the alkali and alkaline earth metals. Groups 3, 4, 5 and 6 contain metals and non-metals. Groups 7 and 0 are non-metals, with group 7 containing the halogens and group 0 being the noble gases. In between groups 2 and 3 are the transition elements, which is a block of metals. All metals in the periodic table will lose their outer electrons during a chemical reaction to form positive ions. This is because a full outer electron shell is the most stable arrangement. All non-metals will gain electrons to achieve this, forming negative ions. Losing or gaining electrons will give the elements the electronic structure of a noble gas. Using the group number, you can work out how many electrons are needed to be lost or gained. For example, an element in group 2 needs to lose 2 electrons, and an element in group 5 will need to gain 3 electrons. The elements in group 0, the noble gases, already have a full outer electron shell, because they have 8 electrons in their outer shell, or 2 electrons in the case of helium. The number of electrons that are lost or gained determines reactivity. It is easier for an atom of an element to lose or gain 1 electron than it is to lose or gain 2 or more. This means that groups 1 and 7 are the most reactive. Group 0 elements are unreactive because they have a full outer electron shell. Metals and non-metals have different physical properties. All metals conduct electricity, whereas most non-metals act as insulators. An exception to this is carbon, which conducts electricity in graphite form. Metals are mostly solids that have a high melting point and are malleable and ductile. Non-metals can be solids, liquids or diatomic gases and have lower melting temperatures than metals. The noble gases are monatomic gases and are very unreactive. Developing the periodic table as we know it was not an easy task. It took the work of many scientists to produce the periodic table we use today. At the start of the 19th century, scientists did not know much about the structure of atoms. At this time, scientists were unable to predict elements that had not been discovered yet. This meant that some compounds were thought of as elements. All these factors made arranging the elements very difficult. Many scientists were involved with the development of the periodic table. One of the first was John Dalton, who ordered the elements by atomic weight. In 1864, another scientist, John Newlands, had his ideas which built on Dalton's. He ordered the known elements by atomic weight. When doing this, he noticed that each element was similar to the element 8 places along. This led him to produce his table showing the law of octaves. One problem with the law of octaves was that Newlands did not leave spaces for undiscovered elements. He assumed that all the elements had been discovered. Another problem was the grouping of certain elements. For example, he grouped oxygen with iron and sulphur, a metal and 2 non-metals together. These issues meant that his ideas were not accepted by other scientists. The real breakthrough came in 1969 by Dmitri Mendeleev. When Mendeleev produced his table, around 50 elements have been discovered. Again, he ordered the elements by atomic weight, but he noticed that the atomic weight of the elements related to their physical and chemical properties. This led him to arrange the elements periodically, with repeating patterns of chemical properties in vertical groups. Unlike John Newlands, Mendeleev left gaps for undiscovered elements, and he used the table to predict the properties of these undiscovered elements. When these elements were discovered, his predictions were proven to be correct, and the elements had places in this table. An example of this was gallium. When it was discovered, his predictions of its properties were correct. Mendeleev's table, however, did have some faults. Argon has a greater atomic weight than potassium. This means that argon should have been in group 1 and potassium should have been in group 0. These groups have chemical properties opposite to the properties of these elements though. Where these issues arose, Mendeleev simply changed the order of the elements so that the chemical properties were similar in the groups. When the structure of atoms was better understood, the elements which broke the pattern could be investigated. It was discovered that the number of neutrons in the atom was causing issues. In order to overcome this, the table was arranged in order of increasing atomic number. This meant that the elements were ordered correctly by increasing atomic number, and that the elements found in the correct groups with similar properties. This is the periodic table which we have today.